Hello everybody! This is our video solution to problem 2 from Quiz 2, Fall 2023, Math 307 here at Cal State Fullerton. And in this problem, we are asked to give an example of a list of two non-zero vectors that does not span R2. Alright, so we gotta be careful here. First, it's a list of vectors. How many? It says a list of two vectors, but they should be non-zero. So we definitely, we know we can add nothing to our span if we had the zero vector, but this says, nope, you need two non-zero vectors. And we want it to span R2? No, does not span R2. Okay, so let's just draw quickly a picture of R2, right? We'll draw our coordinate plane. And if I have a single vector which is non-zero, okay, so maybe it looks something like this. Okay, so there's a vector, any vector I like. What is the span of that vector? So if we called this vector, say, u, the span of u is going to be all multiples of u, meaning we take, say, real numbers, we multiply it by u. And geometrically, what that's going to do is just give us a line going through this vector u. All right, so this here would be the r span of the vector u. What we want to do now is add another vector that is not going to give us, when we take the span of that vector in u, all of R2. And a very easy way to do that is to simply take a vector which is already in the span of u. So, for example, I could take 2 times u. And that would work. So, literally I'm going to write down any non-zero vector I like. So we're going to let u be the vector, I don't know, how about 3, negative 8. Okay, I'm just arbitrarily choosing some numbers here. And we'll let v be the vector, well, how about 2 times u? So 2 times u will be 6, negative 16. So if we take the r span of u and v, because v is already a multiple of u, by the linear dependence lemma we know that the span of just u is equal to the span of v. Okay, so this is by the linear dependence lemma. But we know that the span of u is a proper subspace of R2, right? It's only the stuff on this line, it doesn't contain anything not in there. Okay, so since, well, let's pick something which is not in the span of 3, 8, since, how about 1, 0, right? Since 1, 0 is not in the span of u, okay, so I mean, originally we could have said, oh, it's a subspace, maybe it's equal, but we know that 1, 0 is not in the span of u, so, right? Why, as 1, 0 is not a multiple of u, all right? 3, negative 8, you can't multiply that by something and get 1, 0. So since that's the case, we have that the span of u does not equal R2. And therefore the span of uv does not equal R2. Notice I haven't written the R subscript because that's the only field we're talking about here. Okay, so there we go. We found a list of two non-zero vectors that does not span R2. And again, your answer here should be likely very different from mine in the sense that you shouldn't likely have chosen 3, negative 8, right? That would just be an amazing coincidence. Okay, so, yep, there we go. Things get a little trickier when we go up to 3 dimensions, but that just requires us to look at linear combinations instead of just multiples. All right. So there we go. We will see you next time with more question about the span of a list of vectors.